Hello everybody, this is a companion video that we're making to go along with SE485's Lesson 8 DOE Lab. And what we're going to do in this lab is we're going to learn how to use this statistical program R and how to set it up for design of experiments so that we can analyze the output from our experiments. Okay, so let's go ahead and get started. The first thing that we're going to do is we're going to go ahead and download the stochastic Lanchester output data. What this data is this is data that's coming from a simulation model. So I'm going to go ahead and save this out to my desktop, and I'm going to go ahead and create a file on my desktop that I'm going to call sort of like my Mos Eisley folder on my desktop. So I've got a folder on my desktop that I'm going to keep all my files in. So now that I have my data, I'm going to go ahead and open it up, and we're going to take a look at it and just talk about it just a little bit. So what we have here is we have a set of data that's come from a simulation. In this case, the simulation model we're using is actually a Lanchester simulation. So this is a mathematical model. It uses differential equations to model forces over time. We're going to spend a little bit of time talking about this later in the class. It's very nice models, little coarse but still very useful. So the model basically works like this. You have two forces, red and blue. They have a start. An initial start, what we'll call a nit red and a nit blue, and they attrit each other at a certain rate. So lambda r and lambda blue represents the combat power in terms of how much hurt one force can put on the other. So those are really the main variables for the equation: is how much do you start with and how bad can you hurt the other guy. And there's a nice article in the combat modeling notes that we'll again reference later. But for now, what we're using this is to kind of take the place of iWars to generate some data quickly. But the techniques we're going to talk about into today's video is really applicable to any combat model that you could use. So let's get on with it. So in this model here, you can see how this simulation, these equations, have generated a set of data here. So a nit red, a nit blue, those are the initial starting forces. Then you have your blue kill rate and your red kill rate. Then you have time, so this is how long the simulation took to reach culmination point. And then you have the final red and the final blue. So you can see here in this first kind of run that red won the day at 106 final, and they annihilated the blue. And you can kind of see how things are going. So what we're going to try to do is do an experiment to try to tease out what were the big factors. Was it how much you start with? Is it your kill rate? And how do all these factors interact to determine who wins the battle? So that's our output data. I'm going to go ahead and close that for now, and we're going to go ahead and start with R. Okay, so we're going to go ahead and open up RStudio. So there's R and RStudio. We're going to be working with RStudio, which is a nice integrated development environment for R. I'm going to go ahead and cancel that for now. And I'm going to be following along with the tutorial that's listed in your combat modeling notes. So the combat modeling notes, page 7-9, has this walkthrough that I'm going to be running through. So if you want to print that out or have that handy, I'm going to walk you through it. So the first thing we're going to do is we're going to type in the command library RCmdr, and what that's going to do is that's going to load up the RCmdr, which is sort of a GUI within a GUI, if you will. It's a handy dashboard that will save us from some time, and everything that we can generate with this RCmdr we could type manually down here in the R command line, but this is just a little bit faster, and it's a really nice interface. Now there are some bugs, and we're going to work through those, and I'll point out where those are. Now that I have my RCmdr window open, we're going to go ahead and start setting up our design. So we have to use a plugin for the RCmdr window. So we go under Tools, Load RCmdr Plugins, and we're going to load the plugin here, RCmdr Plugin.DOE. It's going to prompt us about restarting the RCmdr, so go ahead and say yes. It's going to restart it. And then once it restarts, you'll notice we're going to have this design up here. So this means that the plugin successfully loaded. So now we can do design of experiments using the RCmdr GUI. So the first thing it says is we're going to go ahead and create a two-level factorial design. So I go under Design, I hit Create Design, and I'm going to go down to General Full Factorial Experiments, and I'm going to have this window here. So in this experiment, we have 4 factors. We have initial red, initial blue, we have the blue kill rate, and we have the red kill rate. In the simulation, it generated 40 replications per simulation. So we did 40 runs per design point. So we have 40 replications there. I'm going to leave this set at 1 for 1 block. I'm going to hit repeat only, which will allow the runs or the replications to go in order, which will better match my output variables and the simulation. I'm going to unclick randomization here. So this first screen I have, leave this set at design 1, 4 factors and 40. Check repeat only and uncheck that. Now I'm going to go ahead and specify my factor details. So this is where we're going to sort of name our different variables and makes things a lot easier. So my first factor that I'm going to put in is going to be a init red. No spaces, and we know we have 2 levels because it's two-level design. And then now it's going to ask me what my levels are. So here I'm going to enter the levels for my experiment. So the first level that we checked with red was 50, which is our high level, our low level, and 150 was our high level. So then I hit tab, and you'll notice that there's a space between these. So now what I just did is I specified for my init red factor. So this is how much red brings to the battlefield, how many forces they start with. It's either 50 or 150. Then I'm going to go ahead and select blue, my next factor. So this is going to be init blue, and it has 2 levels, and it's going to be 20 and 50. And now I'm going to go down and enter my blue kill rate. 2 levels. And you want to kind of pay attention here because there is an order of magnitude difference between blue and red, which is nice for the blue guys. And you can see it is a little sensitive to input, so just kind of work through things, pay attention. Attention to detail is really important when you're working with this program because it's not very resilient, and it won't give you always the best error messages. So kind of re-verify my design. I've got 2 levels for red, init blue, 2 levels for blue kill rate, and everything looks good. The last thing I'm going to do is just hit OK. It's going to say, hey, you're trying to make something, do you want to override it? Hit yes. And I have my design set up. So, okay, the next thing we're going to do is we're going to export the experiment so that we can work on it and enter our simulation output into the design. So we're going to go under Design, Export, Export Experiment. It's going to bring up a dialog here. So for this, we're going to want to do CSV and RDA. And I'll explain a little bit about what those mean in just a second. We're going to leave the default separator set to where it is, the decimal separator set to default. And then the last thing we need to do is change this working directory to a place where we can remember it. So I'm going to go out here and find my Mos Eisley directory again. Okay, so I'm going to go ahead and open up my Mos Eisley folder, and you'll see I have 2 new files in it that were created by R. There's a CSV and an RDA. The RDA is an internal R file you won't need to worry about. The CSV is where we'll be editing. What's important to know is that both these files kind of have to go together, and if you modify your design, you have to recreate both of these. So let's go ahead and open up the Design 1 CSV. And you'll notice this looks somewhat familiar. It looks a little bit like the output from the simulation. with some extra columns. So we still have a init red, init blue, blue kill rate, but then we have a lot of other stuff over here. So these first 4 columns, if you will, are sort of internal to R's notion of the design of experiments. So we won't mess with these columns, nor do we really want to mess with them. And we really don't want to mess with any of these columns, A through H. What we're going to do is we're going to add in our response variables to the right here. So we're going to take our simulation output data and we're going to append it to this file and then reload this file back into R and have it do its analysis. So it's kind of like we're using R to sort of set us up with a template, and then we're going to modify the template and then have R reread its template back in and do its analysis. This is R is very sensitive to changing this, so we don't want to change these rows, columns, order at all. So all we're going to do is tack on some stuff over here, but everything else has got to stay in order because the CSV is linked to the underlying RDA file. So I'm going to go ahead and minimize this for a second. We're going to go back and we're going to open up our Lanchester output again. So the hardest part of this lab is doing what I would call data manipulation. So we have data that came from one source and we're trying to put it in to another source. So here's my design for R, and I'm alt-tabbing. So this is an alt-tab move, alt-tab, alt-tab. So there's my R design and here's my Lanchester, R, Lanchester. So you get the idea. But a lot of times in analysis, things don't come, the data that you get, that you collect, doesn't match the data that you wanted in. So you'll notice here it wants 50, 20, 0.1, 0.1, and then it does 40 replications of that, of those levels. But our simulation over here is 150, 50, 0.3, 0.07. So you're like, oh man, everything's out of order. So we never ever change the order of our R file. So that means we've got to do something to our output file to kind of get everything squared away. What I recommend you do is add a new column, and we'll just call this order, and we're going to use it sort of as a helper column. And I'm going to go ahead and look through my file. I'm looking for 50, 20.1, 0.01. So like basically everything's low, 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 low. So that's not what we want. That's not what we want. That's not quite what we want. We're almost there here. So low, low, low. This is still high. And I end up finding out that all the way at the end of the file is what I want. So the first 40 runs over here correspond to the last 40 runs over here. So, okay, whatever. I'll go ahead and enter, 1, which means this was kind of like my first replication. Or, I'm sorry, this was my first design point. So I ran my first design point. Be careful here. I ran my first design point 40 times. And I go back into my file here, and I notice that, okay, now it's high, low, low, low. And it's high, low, low, low. Okay. I see where this is going. So now I'm going to enter 2. This is my second design point. And now the next one is 50, 50.1, 0.01. Alright, so it looks like it's exactly reversed. So, what I'm going to do is I'm going to go ahead and put a really big number in up here. And I'm going to count down. There's a lot of different ways to do this. You can sort it, but this will allow me to stay consistent with my data. So now if I do a sort, now I have everything in the right order. Alright, so once you have everything in the right order, if you want to confirm that, what I recommend you do is we're going to go ahead and copy in our response variable. So these first columns in the Lanchester output, it's important to kind of keep note of this up here. These are still, these are sort of the factors of the experiment. I'm interested in the output variables, so I'm interested in these columns. So I'm going to copy these columns. Now I'm going to switch back over to my design, and I'm going to do that append move that I was talking about in the beginning. So that's kind of what we're going for, is we're going to enter the information there. I'm going to go ahead and do a Control Z and undo that. And if you're still concerned that maybe things aren't in the right order, I'm going to bring the whole thing in. So now I've got sort of, this is coming from my simulation output, and this over here, A through H, is from R. What I want to do is do a quick check to see if everything's cool. So I'm going to go if, and I'm going to check, does my initial red equal my initial red over here? So I'm going through and kind of verifying my data manipulation. I put 1 if it is, I put 0 if it's not. So does E2 equal I2? 1, 0. And I can copy that over 4 times. Okay, 1, 1, 1 means everything is aligned. That means my order is right. Now I can go ahead and copy this down and quickly see, I can go over here under conditional formatting, and I can quickly see that, okay, everything's green, and I have all my data is in the right order. So my data manipulation, or my data transformation step in this design is good to go. Alright, so once you're confident that you have everything kind of in the right order, I don't need these columns anymore, so I'm going to delete those. And again, I'm not interested in duplicating these columns because R has already set these up for me. So I'm going to go ahead and delete these. And now I'm left with R's original set of columns for its designs, and I've added the 3 response variables. So at this point, I'm going to go ahead and save my design. I hit yes, and then I'm going to go ahead and close it. Now Excel has this kind of annoying habit of kind of getting you in this recurring loop, this infinite loop when you save CSVs. Because I just saved it, I don't need to save it again. So I'm just going to hit no, and I'm going to go ahead and close my output, and we're ready to proceed with the design. So going back into RCmdr, we're ready to go ahead and reread the design back in. So I go up under Design, and I go to Import, and I go Re-import Experiment from CSV. So I'm going to re-import my template again. So my directory is set there. I have to select my RDA file, and I have to select my CSV file. Keep my separator at default and hit OK. And it loaded my design. If everything worked out, you can hit this View Data Set here, and you'll notice that the View Data Set kind of brings up a little preview of the design. You can see the original design variables, and now I can see that where I've added my response variables over there. So I went ahead and successfully did that. Now we're ready to get into some statistics and start fitting some models. So I go under Statistics, I hit Fit Model, and I want to use a linear model. And I'm going to go ahead and work with this dialog here, which allows me to specify my design. So the first model that we want to look at is to kind of figure out, what is the time in the Lanchester model? What is the culminating time, and how do the various factors such as the initial blue, the initial red, the kill rate for each of those forces, how do all those interplay to determine the length of the battle, or the time? So time in this case is our response variable. So it goes over there. And then over here I'm putting in a left parenthesis, and we're going to build out our design. So we have the initial blue. I can double click that, and then initial red. And then I want my blue kill rate, and I want my red kill rate. So this is basically shorthand for the mathematical notation that you see when you do a regression model. Except we're going to specify here the caret sign and the square term, which means I want all of the interaction, the two-way interaction for the 4 factors. So I've got my 4 factors, and then I want the two-way interactions. I'm not interested in anything beyond that. And then I hit OK. It says something about, hey, you got a model in there already? Yeah, whatever. I delete that, or I hit OK, And you'll notice now down here in my R window, I've got it went ahead and ran my regression on my model, and you can see here where now I can interpret some of this. Initial blue doesn't look like it was significantly a factor. My initial red was highly significant, and it had a positive impact on time. And my blue kill rate drove down time at a significant level, and you can interpret this kind of how we've been working in class. So that's my first model. The next kind of cool thing to do is look at some of the interaction plots. So I'm going to go ahead and do that. I'm going to go before I do that, I'm going to go into R down here. So I actually dropped out of RCmdr and all the way down into the R command line in RStudio. I'm just going to type in Windows. And what Windows does is it brings up a separate graph window, which is kind of handy for plotting. So I'm going to kind of keep that out there. Bring back up my RCmdr. And now I go under, let's see here. Yeah, Design, Analyze Design, and then Main Effect and Interaction Plots. So I'm just going to grab time, and let's look at how the 4 factors do. So just Main Effect Plots, I look at time, I hit OK. And now if I bring up my R window, my graphics window, you can see I've got 4 main effect plots. So this clearly shows that the initial red, as red goes up, so does time. As blue goes up, so does time. As kill rate goes up, time goes down. As red, kill rate goes down. So again, you've got to look at this within the context of the significant levels over here. So these slopes don't really mean anything if they're not significant. But you'll have to reference our notes in class for that. So I'm going to go ahead and go back under Design, Analyze Design, and look at Main Effects. And this time I'm going to hit the Interaction Plots. Selecting all 4, and now I have my interaction plots, and you can interpret those as well. So let's go ahead and look at a different variable this time. So if I go under Design and Analyze Design, Main Effects Plots, say I look at Final Red. I'm going to try to predict who wins the battle. Main Effect Plot, there's my Final Red. Good Final Blue. It's important to pay attention to the title on top of this. And there is a bug with interaction plots. If I hit Final Red and select interaction plots, you'll notice up here it says time. So it's a little bit of a bug in RCmdr. So the way to get around that is to go over here under the window, and you'll see that, hey, last time it's got this IA plot. So the way you fix that is you have to specify the response variable in this final line. So if I want the response, say, to a Final Red, and I'm going to look at the interaction plots, I'm going to paste it in. So I put comma Final Red in there. I'll highlight this final line and hit Submit. And now my interaction plot says Final Red. And I can go ahead and change this to Final Blue. Highlight it and hit Submit. I got Final Blue. Finally, the last thing that you can do is you can save out your results as a PDF or a copy to the clipboard, and then you can paste this right into your report or your homework assignment or whatever it is you're working on. Okay, so that pretty much finishes up the RCmdr DOE Lab. Hope you enjoyed it. If you have any questions, go ahead and talk to your instructor.